Hello and welcome to SudoKanard. We're here to solve this 08 Arrow Sudoku by Indian author Akash Doulani, my good friend. And this was a very hard puzzle in a very hard round, worth 102 points, and they were well deserved. So the special rule, as I explained in the practice puzzle by Akash Doulani a few days ago, is that digits are digits from 0 to 8 instead of 1 to 9, and the sum of all digits along an arrow is the digit in the circle. So there are a few places to start here, and we can see that the sum of those 7 digits is at least the sum of digits from 0 to 6, which is 21, and with those, the minimum is still 21, but 21 is also the maximum value for the sum of those 3 digits, and the sum of those 3 digits is the sum of all those digits in here. So the minimum equals the maximum, so those are exactly digits 6, 7, 8, and those are the digits from 0 to 6, and I won't pencil mark them. Instead, I will pencil mark those two. And so the sum here is 21, which means that those 2 digits have to be 0. So that is a very nice start. And something similar is happening here. The sum of all 6 digits here has a maximum of the sum of all digits from 0 to 5, which is 15, and it's also the minimum value for those. So those are 7 and 8. And those are the digits from 0 to 5, which means that those are 6, 7, 8. And here is exactly the same. So those are 7 and 8, and those are 6, 7, 8. And this is kind of interesting because we can see that 6 is in none of those cells, so that there has to be a 6 in here. So that won't ever be a 6. It's either 601 or 602 to provide a sum like this. We can also see that 0 is somewhere around here, and 0 is somewhere around here. So using all those zeros, we can place the 0 here. And the counterpart here is a 1 or a 2. And here comes a very, very tricky part, which is parity. Because here we have a sum of 21. Here we have this digit and those 2 digits, and those 2 digits sum to this one. So the sum of all those digits is an even number, which means that the sum of all those digits is an odd number. But the sum of all digits on the row is 36, and therefore the sum of those 2 digits is odd. The same logic can be applied on this column, so that the sum of those 2 digits is odd. So we can deduce from that that the sum of all 4 digits here is even, plus those zeros. It means that the sum of those 2 digits is even, which means that they are 6 and 8, and this is 7. As a consequence, those 2 digits are 6 and 1. This is really beautiful. This is really some beautiful setup. I love that. Alright, so now we know that 6 will have to be 2 plus 4, and 8 will have to be 3 plus 5, but we don't know in which order. So this is a really remarkable start to this puzzle. Where is the next place to look? Well, one next place to look, I think, has to do with digit 6. So we already know in this column that 6 is here. But on this row, 6 is not here and not here. So 6 will have to be somewhere there. So, and we'll see that 6 here won't work. Because we have here 7 digits, which means that the sum of all those digits is at least the sum of all digits from 0 to 6. That is at least 21. So I will use some coloring. So those digits sum to at least 21. Plus this, plus that, plus that. So we have at least 0, 0 and 1, which makes a total of 22. So the sum of all green digits here is at least 22. And those digits sum to the same as those 3 digits. And the sum of all 3 digits here is at most 8 plus 8 plus 8, which is 24. So we only have 2 degrees of freedom. And 22 was achieved by assuming that those 2 were zeros. And it means that knowing that we only have 2 degrees of freedom, the maximum value here is actually 2. And knowing that there are not 2, the maximum value is 1. So those are digits from 0 and 1. So this can't be a 6 anymore. That is a 6. I say 2 degrees of freedom. This is not 6. This is at most 8. This is 7 or 8. Same here. And this is not 6. This is from 7, 8. And actually, look at this. One of those digits is 8. So it's not possible for those digits to be both 8. So one of them at least is a 7, which means that the maximum value for those 3 digits is actually 23, not 24. The minimum value is 22, and the maximum value is 23. So we only have 1 degree of freedom. So those digits are, the minimum was achieved by 0, 1, but it can still be 0 and 2. So there has to be a 0 in here. And one important point here is that if I try to make this 0, then those are 1s, and I eat 2 degrees of freedom, but I only have 1 degree of freedom. So this is not possible. That is not a 0. This is a 0. And now, by the rules of Sudoku, this has to be a 0. All right, this is really, really nice. So 0 will be around here. So we have only 1 degree of freedom. So in the maximum scenario, this is 0. This is, if this is 8, so no, sorry, I'm being inarticulate here. So in the minimum scenario, those are the digits from 0 to 6. In the maximum scenario, they are the digits from 0 to 5 and the 7. But in this scenario, where does 6 go? It can't be into this cell. So actually, this is not possible. The maximum scenario for those digits is not possible. It has to be the minimum scenario, which means that those are digits from 0 to 6, and this is from 7, 8. All right, so those sum to 21. But if this is 1, then this becomes a 2. And we eat 2 degrees of freedom. That doesn't work, so that has to be a 0. So the only degree of freedom is here. If so, oh, and so the minimum value is with 2 7s from those digits, and the other scenario is with well, 22 is with 7, 7, 8, and 23 is with 7, 8, and 8. Let's look at this digit. This plus that is that. So this has to be from 5, 6, and 7. No, 7 is not available. That has to be from 5 and 6. Now I don't remember what the next step is. I truly don't. What about this? Well, where is the next step? That is a real question. And I truly don't remember. So maybe, yes, we have a 0 and 2 here. So we get a 0, 2 pair in those cells. Yes, the real question here on this row, this is from 6, 7, 8, this is from 7, 8. Where is the third such digit? And that is a real question. In other words, 7 and 8 are not in here. One of them is here, the other one must be here. That's a 6. But now, where is 6 on this row? Well, it must be somewhere here. But could 6 be one of them here? Could 6 be here? Actually, I think it could. 6 here. But first, the logic I just applied to this row can be applied to this column as well. None of those digits is 7 or 8, so the second 7 or 8 must be somewhere in here. It can only be here. So that this is 6. Now, looking at all those 6's, we just get the 6 into this cell. Which means that this digit here determines that. So the degree of freedom is both here and there. And I think those two digits sum to 15. That seems to be correct. That's not helping me that much, I'm afraid. So what is the next step? I don't remember. Oh, well, so I have to find it again. Perhaps it's about, yes, it's about the second 7 or 8 in this region. Because we can see that it's not here. We can see with those digits that it's not here. So the second 7 or 8 is here, and because of this 7, this is 8. 7 here, 7 there, 8 there, 7, 8, 8 here, 7 there, 8, 6, and 8. Yes, that's it. And now that this is 6, this has to be 1. 1 is not here. This is from 3 and 5. 1 is here. All right, so now now that this is 6, those must be 2 and 4. Now that this is 8, those must be 3 and 5. This is the sum of those two digits. 1 has to be here and there. So this is from 2 and 4, this is from 3 and 5. Right, but now this 3 is not here, so this 3 is around here, which means that this is 5, this is 3. And those are from 2, 3, and 4. Those are from 2, 4, 5. So this is 4 or 5. This is 2 or 5. I need a 6 down there. What about this? I still need a 7 here. Those are 1 and 4. So that this is not 4. This row still needs 2, 3, and 5. Well, this is never a 2. And this is really interesting. The remaining digits in this, there is a 1 somewhere, and this is from 2 and 4. This is still not resolved. How are we doing this? Here I need, what am I doing? This 6 is going there. Oh, this is not from 2 and 3. This is from 3 and 5. This is actually a 3. I hope I didn't mess up too much. So this is 5. This is 4. 5, 2, 2, 4, 2, 3, 5, 3, 2, and 4. I hope this is correct. This 6 now tells us that this is 1, this is 6. This has to be 6, this has to be a 4, and this has to be a 5. I think it's working. So now those 3 digits are 1, 3, and 4, whose sum is 8. This is 7, this is 8, this is 7, this is 8, this is 7. Here I need 2 and 3. But now the sum will be here 1, 2, and 4. 7 here will be 1, 2, and 4. That's the 3, that's the 2. This is 0, 3, 5. And this is not 1, this is not 4, this is not 2. This is not 3. Down there I need 0, 2, and 5, so this is 5. Those are 0 and 2. And this can only be a 5. So that this is 3, this is 0, this is 5, this 0 turns this into a 2, and this is 1 for this sum of 8 to apply. That is 0, 1, 4, 2, 4 here, 3 there, this is 7 indeed, 4 here, 1, 4, 0, 2, 3, and 1, and this is it. So this was absolutely spectacular. This is really an excellent puzzle. I would say, in my opinion, this is the best puzzle in the set. It's definitely hard, and 102 points sound right to me for this puzzle. To be honest, I did bifurcate when I solved it in limited time. I made sure I wouldn't bifurcate for this video because there is no need to bifurcate, but truly a remarkable puzzle. And thanks for watching this video. Thanks, Akash, for this amazing stuff, and see you soon on SudoKanard.